Yeah, I have to admit, when I think Microsoft employee, Ivan is not the first image that jumps to mind. So yeah, it's very interesting. Good afternoon. Thank you so much for being here. I know it's the time of the afternoon, at least when I go to conferences, where my brain starts turning into oatmeal because of all the awesome stuff that I've been listening to all day. So I will try and shake it up a little bit. So the first thing I'm going to tell you actually is that I have brought you here under false pretenses. This is not actually the talk I'm going to do today. And I realized this as I was looking through the program, that I have named this talk extremely badly. Because it tells you what the talk is about, but it tells you nothing at all about why you might want to come listen to the talk. And so I'm kind of surprised that anybody showed up at all, so thank you very much for coming. Because I gave you basically no information about why you should be interested in anything that I'm about to say. So I thought I would try renaming it. I thought about it for a while. So the talk is really explaining a theory that I've been working on about software teams. So we could change that out of the tagline, right? But it still doesn't tell you why. Like, why would you care about a theory of software teams? What is that going to help you do? And so finally, a few days ago, when I had 15 hours on a plane on the way here, I figured out that the theory is important basically just because as developers, we want to build more awesome stuff. We want to be on teams that work well together. We want to be on teams that treat us well, and ultimately what we want to do is produce interesting and useful software. And a theory of software teams can help you get there. So that's what I'm going to give you today, a set of tools that help you understand how software teams work so that you can build more awesome stuff. So clearly I should have put this in the program. So this is me. I'm Sarah May. I'm based in San Francisco. This is my Twitter handle. I pretty much use Twitter for all of my communication. You can try and send me an email, but it'll just get lost in the void. And I've done a lot of Ruby work, as Ian mentioned. I do a lot of JavaScript also. I do a lot of nonprofit work. I'm one of the founders of RailsBridge and Bridge Foundry. And now we have like Closure Bridge and GoBridge, just basically organizations that are working to bring more diversity into their respective technical communities. So if anyone in here wants to do like C# Bridge or anything, let me know. I'm also one of the directors of Ruby Central, which means that I run RubyConf and RailsConf, which are the two largest Ruby conferences in the world. I also, though, that's sort of like all of that stuff is sort of on the side. I actually am a developer for the most part. I do software consulting with a company called DevMind, and I want to be like sort of excruciatingly clear about what that means, because I think it'll help set the right context for what I'm going to talk about later. So when people say they do software consulting, there's usually one of two things that they mean. Some people say software consulting, what they mean is that they work on projects. So a company needs a thing built. Consultants will build the thing. Usually these people work pretty independently from the client. Any developers that the client might have, they don't really work together. They're a little bit separate. They may work with other developers from their own company. And then there's another type of consultant that works on business stuff, and these are the people from the Deloittes and the Andersons of the world, right? These are the people that do agile transformations and process consulting. And they do get involved with the customer. They usually come and sit with the customer on site, but they probably don't write any code. And so neither of these are really what I do. I do a sort of hybrid of these things, and that is that I work on teams. I work on software teams made up of developers and designers and QA and product managers and project managers. And I usually work with teams that are transitioning from one size to another, who are going from 8 to 12 or from 30 to 60 or whatever. And I help them figure out how to navigate those transitions. So I see a lot of teams. And these transitions usually mean some combination of code changes and process changes, and that sounds probably a bit like agile transformation. But the difference in my mind is that the way that I figure out what to recommend is that I kind of move in, right? I go on site to their office, and I pair program with their developers, and I participate in their meetings, and I try to nudge them in the right direction. And generally, my goal is to make them more effective. I want to turn them into a high-function team. Now, I don't have a system for this or a checklist, because each team is different and needs different things. Although apparently, if I had such a system, I could write it into a book and make $1 million. This is what people tell me. If you're a consultant, you're supposed to have a system. I'll work on that, I guess. So I don't have a system right now, but what I do have is a particular way that I think about teams and team interactions that is non-standard. And it helps me figure out what to do to help teams move forward. And so I think it might be able to help you figure out how to move your own team forward. And so that's what I'm going to share with you today. Now, before we get to that, I want to talk briefly about what a high-function team is. These are the kinds of teams we all want to be on. We may not realize that we want to be on them because there aren't very many of them, to be honest. And a lot of developers have never been on one. And what they feel like is they feel collaborative. A high-function team communicates really well. They're thoughtful. And the crucial other half of it is that they get stuff done. And they're productive. And I don't mean productive in the sense that a manager thinks of productivity like lines of code or hitting their quarterly numbers or whatever. What I mean by productive is that they're getting the stuff done that matters. They're building the right thing. They're not just building something. And the effort that they're putting into their code is going towards solving a real problem. So that's what I mean by high-function team. I'm being a bit vague because high function really is more qualitative than it is quantitative, which is another way of saying basically that we just haven't found metrics yet that tell us when a team is high function. Now, despite that, there are ways we can make more of them. And that's my personal crusade, because after I graduated from college with my computer science degree, I spent 10 years in the industry before I was on my first high-functioning team. Now, work on other teams isn't bad. I mean, I would have left the industry long before 10 years were up if I didn't enjoy it. But when I started on a high-functioning team, it really felt materially different. I was like, oh, so this is what software is supposed to feel like. This is awesome. It felt like we were working together on a goal that was larger than ourselves as individuals. We all had different roles. We had developers and PMs and QA and so on. But we respected and trusted each other. We knew that we were working towards the same goals. And we sort of pulled together towards them as a unit. And we built some really amazing things that solved real problems. And it was at that point in my career that I realized that I like programming. And I'm pretty good at it. But programming itself is not what appeals to me about software. It's not what motivates me to be in this industry. I'm motivated by writing useful code that helps actual people. I'm motivated by getting the stuff that matters done. And I'm not motivated as much by the construction process. This morning, Catherine Daniels said in her keynote in the context of operations code, she said, I don't write code for the fun of it, I write code to solve problems. And that resonated with me. But in many ways, I mean, it would be easier for me if I were motivated by programming itself, because most software projects fail. They fail to produce anything of lasting value. Project gets canceled, code base is shelved, company goes under, or even worse, project is launched, fails to attract any interest or users. One study that I found said that 68% of software projects fail in that way. That's 2 out of 3, more than 2 out of 3. So if you're motivated by building the right thing, if you're motivated by actually solving problems with your code, it can be a tough world out there. And the most difficult part about that 68% figure is that we really don't know why so many projects fail. Projects fail despite our personal best efforts, despite putting the A team on a project, despite 20 years of large-scale conversion to Agile, despite developer tools and languages that have been constantly improving. Now, this morning, after Gary's talk, when he talked about Git, I was sitting at a table and I was talking to the folks there about thinking about how much brain power we no longer have to spend worrying about things like version control. And there's a lot of things like that. There's a lot of things that we used to spend a tremendous amount of time and energy on that we don't anymore. We don't have to. That brain power is available for something else. But our project failure rate really has not improved. Now, in a very basic sense, right, projects fail because developers are building the wrong thing. We're the ones that have our hands on the keyboard. And we often have the best information about whether what we're building is the right thing. Now, let me give you an example. So one of my first projects out of school, we were building an application for the higher education market on top of a document store. Now, this was the 90s. There's no MongoDB. Document stores were a very new technology. And the only reason we were using it is because we had received a memo written out on paper that said we needed to use this document store in the project for corporate strategy reasons. Document stores, as you know, are very good at storing documents. However, the developers, we all knew that what we had to store wasn't really documents, and that it would be awkward at best and a disaster at worst. And so with this knowledge, we worked our way up the chain to the VP, who said basically, very bluntly, that the company needed a product that uses a document store, and we were it. So we thought, okay, well, maybe we can change the idea of the product to be something that's more document store appropriate. So we tried that, but then we ran into a wall there because this was a joint project, and the other VP was very attached to this project as it existed. So rather than try and navigate those treacherous waters of internal politics, my boss sent the most experienced engineer off to do data store integration. A month later, not working. 2 months later, well, not really working. 3 months later, not actually working. 4 months later, technically working. Still too slow. The bottleneck was the data store itself. This was, as I said, new technology. Wasn't used to the load that we were trying to put on it. And so about a month after that, the project was shelved. And the official reason that was recorded as the reason that the project failed was that the data store was too slow. And so this looks like a technical failure. It looks like a problem with our technology. But the reason this project failed actually has very little to do with technology. It's all about, this was a communication failure. Neither of those VPs wanted the project to fail. But they did ask for mutually incompatible things, and the only people who knew that were the developers, who were actually trying to take these mutually incompatible requirements and make them real. And the people who are making the thing often have the best information about when a project is about to go horribly wrong. So what if we had been able to navigate? What if we had a map of some kind? What if we could get them in a room together? Maybe the data store being too slow wouldn't have mattered. In the end, of course, neither VP got what they wanted, which means, of course, they were both promoted. And what was so difficult for me about this project that made me think about it on and off for years afterwards was that I was really happy with the code I had written on this project. Our code was great. When I started on that project, I walked into my office and I found a copy of Code Complete on my desk. This was back when that was pretty much it as far as software craftsmanship manuals goes. The team valued well-factored code, comprehensive tests, good documentation. I wrote all of those things, but I left the project feeling like a failure, despite all the fantastic code I wrote, because all that work had just been thrown away. And I didn't understand what had happened. I'd done all the things right that all the books told me to do. But it wasn't enough. And years later, after seeing that pattern probably many more times than I should have in order to see the pattern, I finally figured it out. Our code was great. Our project failed. Clean code is great. Tested code is great. It's not enough. So to succeed in this new world of software, to build something actually useful, we need to widen our focus away from just the code and start looking at the real hard problems of software. And this can be difficult because sometimes it feels like all we have control over in reality is the code, and sometimes not even that, right? If you were at Andrea's talk this morning, like building something inside of Visual Studio, even then you don't have control over a lot of the code you're working with. But I want to challenge you to think a little bit bigger. It is possible to affect the project beyond the code, and you're capable of doing it. And it may take some practice. Perhaps you've seen this quote before from the management theorist Peter Drucker. There is surely nothing quite so useless as doing with great efficiency what should not be done at all. And when he was talking about in general, in sort of the corporate world, he studied GE in the 40s and 50s. And sometimes I feel like when we argue about test frameworks or mocking styles or tabs versus spaces or C# versus Java or Vim versus IntelliJ, what we're doing is we are making things more efficient. We're making our process more efficient. We're making our code more efficient. We are achieving great efficiency. But there's a more important question for us to consider, at least periodically, and that's, is this worth doing at all? Now, it sounds like the purview of the business folks, but remember, you've got your hands on the keyboard. Of anyone in the organization, you have the best information about how it's going. And as a result, as developers, we have control over more than we realize. And we have a lot of hard problems, but they all have one thing in common, and that is they may look technical, but they're all people problems. You probably have seen this before. There's only two hard things in computer science: cache invalidation and naming things. This is attributed to Phil Carlton, computer scientist. There's another variation of this saying that I like quite a bit that is not from Phil Carlson. There's only two hard things in computer science: cache invalidation, naming things, and off by one errors. Get it? There's two hard things. Anyway, yeah. So I think this is actually a very clever saying, even if you take the joke out, right? I think this is actually a very interesting thing, and people have trotted this out in the service of a lot of different ideas. And they sound a bit flippant, right? But I want to dig into them because there's some hidden depth in both of these things, and I want to deconstruct it a bit. Let's start with cache invalidation. So cache invalidation is a fancy term that basically just means knowing when an expensive operation needs to be repeated. Right? For example, let's say you have a method that does some fancy calculations on one of your tables. Table happened to be quite large, so this method takes 3 minutes to run when you call it. Then on the next request, you have to call it again, takes another 3 minutes. If these requests are so close together that nothing actually changes, then you might decide to cache the result, meaning you run it the first time, and then you save the result somewhere, maybe Redis. And then the next request can avoid running the expensive call, perhaps saving you some time. So cache invalidation in this case is knowing when it is that you do need to rerun that method. When do you need to incur that 3-minute penalty to rerun the method? At some point, someone will insert a new row or delete a row or modify a row that will affect the values that come back from that call. And at that point, if you return the cached result, you're dealing with out-of-date information. So part of cache invalidation is knowing when the result would be different if you reran the calculation. That's complicated but straightforward. But there's another element to cache invalidation, and that's knowing when the application actually needs up-to-date data. Maybe this scope calculates some stats for the last 24 hours, but people really only care about looking at data for the previous calendar day. Oops, there we go. In which case, it's fine to generate the result once at midnight, cache it, use it for the next 24 hours till the following midnight, when you invalidate the cache and rerun the calculation. So even though the value of the calculation changes over the course of the day, the application doesn't need updated data, or even want it in this case, until the following midnight. On the other hand, if this method returned new messages for a chat app, invalidating the cache only once every 24 hours probably means no one would use your chat. So this part of cache invalidation, knowing when you need to do it, is not a technical problem. It's a product problem. It's a people problem. You have to understand how the data will be used and who will be using it and what the business finds acceptable. And at this point, we leave the logical realm of code and we enter the squishy realm of people. The technical aspects of cache invalidation are straightforward. It's the people part that makes it hard. Let's talk about naming things. Cache invalidation generally acknowledged as a hard problem, but naming things sounds like the joke, right? What's the big deal about calling things foo or bar or x or function? I hope you'll forgive the jQuery example. I see this a lot in JavaScript. So the name data here doesn't really give us any information. What is the data for? What kind of data? The implications of naming things is actually quite large. You want names that are at the right level of abstraction to support refactoring. Now, where I run into trouble sometimes is I don't know where the right level of abstraction is. Data is too general, but I don't want to be too specific. So the way I think about it is that when you can give something a name that describes both what it is and what it's for, then that means you understand the concept that that variable is representing. And by what it is, I don't mean its type, right, like string or array. I mean what it is one level up from that. The name data in our previous example was actually one level up from that, right? You could have called it object or JSON or something. What it's for is the harder question to answer. And again, that's another level up from the programming world towards the business world. Is this a list of the user's posts? Is it a set of search results? And once you can give something a name that satisfies both these criteria, it means the abstraction you're using is the right one. And understanding what abstractions you need and when to evolve them is the fundamental skill of object-oriented software development. So when Phil Carlton says that naming things is one of two hard problems of software, it's a bit tongue-in-cheek, right? Because naming things is a problem of understanding. You have to understand both the implementation and the application goals. Naming things is the layer where those two concerns interface, and that's what makes it so hard. So neither of these things really are hard for technical reasons. They're both hard because understanding the application's goals is difficult. Understanding business goals is hard. Understanding people and how those people should interface with your code is hard. And so I think this saying is due for an update. And I've been saying this in a couple of different ways. Maybe we'll sort of A/B test. You can see which one gets more tweets. So one of the ways that I've been talking about this is that software is people and only incidentally computers. What we're doing is we're solving problems for people. We're building things on top of people. And we're building representations of people. We happen to do so with computers. And the other way that I've been talking about this is that there's only one hard thing in software, and that's people. And I do think, though, it's useful for us to get a bit more specific here. What's hard about people? What are the hard problems? Can we enumerate these stretches of treacherous water we keep encountering? Now, I've shown you some examples of things that don't look like people problems, but actually are. Is it possible for us to generalize? Clearly, I think it is. In my consulting work, I've seen a lot of teams struggle with a lot of problems that on the surface look very different, but I think fall into four basic categories. The first is hiring. Why is it that if you hire a single bad hire, if you hire someone a single person who's sort of mean or overbearing, into a team that's doing really well, the whole thing can start falling apart? Why is one person so important in a team? Second, turnover. Why is it that when one person quits, you can spend months recovering, even though it seems like they weren't necessarily the most productive member of the team? Third, why is it that when you double the size of your team, you don't get twice as much done? And finally, why is it that there are no good metrics that measure developer productivity? We all know that lines of code are not a good metric. And none of the other things we've ever tried to measure are good either. So these are hard problems, and they all have to do with people. And these are the questions that cut right to the heart of why projects succeed and fail, and why we can't predict them even when they do succeed. And all of these questions are about people, and our current models of software development are not really equipped to help us answer these. Now, our current models for software development tell us that we are building a product. That's generally how we talk about what we do. We're building a product, which is a bit of a holdover from the original days of software when maybe it was a bit more like an assembly line. Shipping code is an interesting one, right? Shipping implies that it's going to roll off the end of an assembly line into a box, we're going to tape it shut, and it will now leave my possession. But when you're shipping something 5 times a day, does it ever really leave your possession? What does that even mean? We talk about maintenance as distinguished from development, as though our code were like a washing machine, right? And once it leaves the factory, nothing new is ever added. All that we do is fix things that break. And so a lot of our underpinning ideas about software development are treating software as though it were done in sort of an assembly line factory manner. And not a modern factory, but like an industrial revolution era factory, in which the car rolls down the assembly line, each person does one thing, and then it rolls off the end and we never see it again. But the factory model doesn't really tell us anything about people. The people are invisible, really. If they're there at all, they're just workers doing the same thing over and over and over again, someday to be replaced by robots. And so this is the model that we currently hold, somewhat unconsciously, about software. And this is why the problems we have are our problems, because it doesn't give us any guidance. Why can one higher up set the team? Doesn't really give you any answers. Factory workers, old industrial era factory workers didn't really collaborate, so why it wouldn't really matter if you hire one person. So it doesn't really help you. Turnover, why is turnover so expensive? Well, it doesn't help you there either. Factory, it's not. If you have each job is a very simple thing that you do over and over again, like that doesn't make any sense. Why don't you get twice the output from twice the number of developers? Can't you just build another assembly line? No, that doesn't help us at all. And productivity, I mean, you can probably tell from the word, it's got the word product right in there. Productivity actually is an Industrial Revolution era concept that did not exist previously. It basically was counting the number of things that fall off the end of the assembly line minus the defective ones. That's what productivity meant originally. So it doesn't really help us here either. And beyond this, like, how much is the software we build today really like a physical product? Certainly not the web applications that we build in the Ruby community. Most desktop software these days is web views. The ones that aren't auto-update themselves. Video games used to be a little bit more self-contained, but even these days with Steam and things like this, a video game is never even really completely done. And so not only does the factory model fail to help us with our hard problems, the words and the concepts it gives us don't even really fit anymore. We don't notice, because those are the only words we have. And it doesn't invalidate the model necessarily to point that out, because we've used this model for 60 years. It's built us some really awesome stuff. Let's talk about models for a moment. Human brains really like to build models, especially human brains belonging to developers. We build complex representations in our heads about how systems work. This is what we do. And the quality of our internal model is what we call our understanding. And our model is good the more it can both explain and predict behavior of the system in the real world. So some models are explicit, as we see a system and we load it into our brains, like an airflow turbulence model or a complex software system. And other models are implicit, like our factory model for software. We don't see it as a system so much as just kind of the way things are done. It's the way things are. But humans have a really grand tradition of taking these implicit models and turning them into explicit ones when it's useful to do so. I think that time has come for us. And this time came for public health in Europe about 200 years ago. And so I want to look at that. I think it'll help us figure out what's happening here. Until about 200 years ago, the prevailing model for how infectious diseases were spread was called miasma. Now, they didn't call it a miasma theory, because this was just how it worked. There's no theory. Now, miasma literally means bad air. The theory said that decomposing organic matter released poisonous particles into the air, particularly the night air, and breathing that bad air is what made people sick. Essentially equated bad smells and night air with disease. Swamps, in particular, were thought to be unhealthy because of the miasma that they produced. Here is an illustration from Europe in the 1830s showing cholera invading as a poisonous vapor. Now, this seems quite simplistic now, looking at it backwards through time. But it endured across many different cultures for thousands of years because it does actually reasonably explain some of the things that we see infectious diseases do. For example, people in close proximity to one another often get the same disease. They're breathing the same air. Seems logical they'd be exposed to the same poisonous particles. And miasma also suggested actions to reduce disease that actually worked. For example, the City of London built sewers and cleaned up garbage from the streets because they thought the bad smells were causing disease. What they actually did when they did that was that they removed sources of drinking water contamination. And another example, back in the day, it was said that you must close your windows at night to keep the bad air out. Closing your windows at night also keeps the mosquitoes out. And so the interesting thing about the miasma model was that it was not fully correct, but it was nevertheless extremely useful. Louis Pasteur proposed a more correct model in 1861 called germ theory, which says that disease is caused by microorganisms that may be present in a variety of different media, such as air and water and skin and blood. and spread by many different vectors, including airborne, but also ingestion, direct contact, insects. So it was at this point, once Pasteur proposed the germ model, that the miasma model was organized and named in order to contrast what we had thought had happened and this new idea of what we think is happening. And this discovery is often presented to history students as a revolution. But the truth of the matter is that when Pasteur published his paper in 1861, very few people were surprised. Because it turns out that in the years leading up to that publication, both scientists and the public were well aware that their current model for disease had difficulty explaining everything they saw. They lacked a coherent alternative, but they could see that their model had problems. Sexually transmitted diseases, for one thing, not easily explained by miasma. But the big one was cholera. This is what made the difference. Starting in 1842, cholera spread out of India along seaborne trade routes, which is very difficult to explain via the miasma theory. You can do it if you really want to. Well, maybe the miasma was trapped in the holds of the ships, and then when they got there, it was released. I don't know, right? You can make it work, but it's a stretch. People noticed it was a stretch. And this was the first disease that they saw that spread in a way that was not easily explained by their theory. But they struggled along with the theory for a good 30 years because they didn't have an alternative, and it worked okay. Cholera presented a new set of problems, which led to the development, eventually, of a more nuanced and complicated model for disease, for the way the diseases are spread. And that's kind of where we are with software. We have a model that's served us pretty well for 50 years. Parts of it still do, but in the last 15 years, software has changed. The way that we build it has changed, and even the nature of what we build has changed. Our model needs to change with it. George Box is the father of modern statistics. He likes to say the most that can be expected from any model is that it supply a useful approximation to reality. All models are wrong. Some models are useful. And what that means is germ theory is not entirely correct. Germ theory is wrong. We don't know what exactly is right, but we've noticed many things about it that we can't explain. For example, many diseases seem to have a genetic component that's not covered by germ theory. There are lots of things that we see that tell us that germ theory is not entirely correct, but it's the best we have right now. And pretty soon, something else will come along to replace it. And so we're at that point with software. So cholera put into really sharp relief for people the limitations of miasma. And web development and mobile development has put into sharp relief for us the limitations of the factory. And those limitations that we're seeing are the human ones. We need a different model that shows us what the human side of what we're doing. Now, there have been a couple of attempts at new models. One of them is the software craftsmanship movement. Perhaps you're familiar with that. I call it the workshop. In our factory, our model for building software centers on the assembly line, where workers are interchangeable. In a workshop, our model for building software centers on a team of developers of different skill and experience levels, building a high-quality, bespoke product. So this harkens back to pre-industrial days where manufacturers, like blacksmiths and glassblowers and so on, were trusted to do their job, not treated like replaceable resources. And the software craftsmanship movement sometimes takes this quite literally. Like there are companies that use the term master and journeyman and apprentice as actual job titles, which to me feels a bit like programming cosplay or something. Now the workshop model is an interesting one, and it does answer more of our people questions than the factory model does. It does help us with our hiring question, right? Factory workers don't collaborate, but a workshop is a very small, tight-knit team. Making one bad hire can upset that balance. So it does have a reasonable answer for that. Turnover has a reasonable answer for as well. In the workshop model, you can spend years sometimes training a person up from no knowledge all the way up to master, journeyman, apprentice, all that stuff. And so if they leave sometime during that time period, you lose that investment, and that's why turnover is expensive. That's a reasonable one. Where it stops being helpful is something like this. Why don't you get twice the amount of output from twice the number of developers? If you hire twice as many glassblowers, I don't know, couldn't you blow twice as many glass things? I don't know. Doesn't really help. So productivity is the same thing. The workshop model is still focused on building a thing. And so it doesn't really help us here, because really the only way to tell how productive a workshop is look at the number of swords or whatever that it builds. So it doesn't really help us here. So we're 2 for 4. That's good. And the workshop model, I feel like, is halfway there. It pulls focus away from the product and puts it more on the people, but is still fundamentally a manufacturing-oriented metaphor, which is like a thing. We make a thing, and that is what we do. And so maybe it's the making thing part that we need to look at. Maybe comparing software to a physical thing is what we need to change. But what can replace that? Software as a thing is very deeply embedded in our psyche, in our way of thinking about what we are and what we do. Like, what is software if it's not making something? There's even an entire maker movement that is oriented around owning this word make. We make things. What do we do if we're not building products? How do we talk about what we do without using those words? Who are we if we're not makers? I go to a lot of conferences, a lot of Ruby conferences, JavaScript conferences, and one of the interesting overlaps I've noticed over the years is that there's a lot of developers who are interested in or previously involved in the theater, so plays, live acting, and musicals and stuff like that. There's other overlaps, right? Our community also has a lot of musicians, a lot of economists. But theater always kind of struck me as the odd one out. Economics is mathematical, music can be mathematical. Theater is kind of a different beast, and I started wondering about this. So I did some theater in high school. That was a long time ago. And I saw some interesting parallels, but I felt like I didn't have really the experience to make these myself. So I did a bunch of research and reading, and I talked to a bunch of people who do more theater than I do. Some of whom are professional theater folks who are now developers. And I started realizing that I think about software as though we're like putting together a play, as though we're on a stage. I've been calling it the stage model. So when a theater production starts to come together, usually all they have at that point is a director and a script. They've decided what play they're going to do and who's going to run it. Now the script is just a skeleton, it's just dialogue. Hamlet was written 400 years ago, but there are some productions of Hamlet today that actually say the same words as the productions that were made 400 years ago. But the two productions of the same script can be dramatically different, even though the same words are said. And one of the main reasons for that is that the actors bring something to the script. They decide how to play the characters, and that makes a huge difference. The actors put flesh on the bones of the script. Just like the product person can have the bones of an idea, but it's a team that really makes that idea real. Now, you probably know if you give 2 different software teams the same project, they'll produce dramatically different solutions. Even if you give the same project, the same team, the same project twice, like a rewrite, they'll come up with dramatically different solutions then too. And the same goes for a play. You give 2 different groups of actors the same play, and they'll come up with something completely different, even though they say the same words. And so once the director has an initial set of actors, they all get together in a room and do something called a read-through. And this is where they start figuring out how their character relates to the other characters. Now, this is a combination of how they are imagining it, how the director's ideas from other people on the cast. And people often change their minds during this period about how they want to play their character, based on input and experiences in the read-throughs. Now, they may try a few different approaches to see which one works best. Should you play Macbeth as an insane man in a sane world, or as a sane man in an insane world? Both are possible, and that's why that play is still relevant to us 400 years later. There's a lot of space in between the lines of a play. This is where the actors make these initial decisions about what goes there, which is not unlike a software team adapting to different personalities, right? Maybe you're a full-stack developer, you're all full-stack developers, but there's one person that really knows SQL really well and really loves it, and the rest of you are just kind of happy to let them do that. You adjust what you do and what you work on based on who you're working with. And the capabilities of the team also affect the solution, right? Maybe given the same web project, both teams would make, in my case, a Rails app, but The one with some really great JavaScript people is likely to gravitate towards a single page app. Maybe the ones without JavaScript would do a server-oriented solution. And you also adjust how you work based on who you're working with. Maybe you're working with someone that's in a time zone 3 hours over. You might adjust your working day so that you can have more overlap. So we all adjust our work based on who we're working with, not just on our own personal preferences or on the dictates of product. So once we're done doing read-throughs, a couple of things happen. First, the actors go off and do some work on their own. They memorize their lines. They watch other people's productions of their character. They do a bunch of self-study on their own. And at the same time, they're getting together and doing rehearsals. Now, as they rehearse, the play gets more and more fully formed, right? As the lighting, costume, sound, all that stuff starts coming together. And it becomes harder, or at least less convenient, to rethink their original decisions. So they're being creative. They're changing things. They're gelling as a unit. They're finding their path. But this is sort of not unlike the fact that the more you work on an application, the harder it gets to rethink your choice of JavaScript framework, for example. Or even harder to rethink your choice of back-end language. So at best, you can make small corrections. And that's because in both cases, you're up against a deadline. And for a theater group, that's opening night. The theater group can be creative. They can work together. They can try and find something. They can try and gel. But opening night doesn't move. Opening night comes, they're going to go out there and they're going to do something. And that's kind of like what we often have a date where it's like, well, we better have something by that date. A theater troupe practices creativity on a deadline. Now, what they go out there and do on opening night may be embarrassing the first few times, right? Which is why, in the States at least, like large theatrical productions often start in a smaller market like Chicago before they move to Broadway in New York. Much like if you're launching a product, you might launch it to a closed group of friendly people before you launch it to the public at large to give you feedback. So there's a lot of parallels for me in how a software team works on code and how a troupe of actors creates a play. I want to say a bit about performance. So if you're like me and you have somewhat limited experience working behind the scenes at theater productions, you might think that once the performances start, all the creative work is done, right? At that point, it's just execution. And this is sort of similar to this idea of like, well, we develop the product and then we go into maintenance mode. It turns out that's not quite it. So a play needs a live audience to really be real. So the actors play off the energy that the audience brings. The same play will be quite different for a matinee of school children than it will be for a Friday night crowd. And the actors also see how people react in general to their characters, and they adjust depending on what resonates with the audience. Which is kind of like you launch a feature, and the way that your users use it or don't use it will surprise you. And good teams can incorporate that usage information and customer feedback into their creative process, just like a good theater troupe can. So let's go back to our hard problems. Why is it that if you hire a single asshole, the whole thing goes to shit? Well, if you're thinking about a troupe of actors, that's pretty obvious, right? They depend on trust. Psychological research tells us that in order to get to the right idea, you have to go through the wrong ones, which means in order to get to the best solution, you need to trust your coworkers enough to be able to put the wrong answers out there without fear. And if you have one person in there that causes that fear, the whole thing shuts down. You won't even be able to enter that process, and you won't be able to find the answers that you need. So that helps us with that. Turnover. Why is it that when one person quits, you can spend months recovering? You know, when a set of actors is putting together a play, swapping out a character halfway through rehearsals has huge ramifications. It's not like you can just bring someone in that's going to do exactly the same thing. You can bring someone in, but they're going to have their own ideas about how that character should be played. And basically, that entire web of negotiated communications has to be renegotiated when you replace someone, even if they seem like a fairly minor character. And it's the same on a software team. If you lose an engineer, even if you're able to hire for that position quickly, which good luck with that, you're never going to get the exact same skill set, right? They'll have different strengths and interests, different blind spots, different weaknesses. And so if your dev who did most of the SQL quits, then you might have to take that on hand off some of the back-end stuff to someone else who maybe previously was mostly doing front-end. So personnel changes, any kind of personnel change causes a sea of invisible renegotiation of roles. And it can take a while to get back to stability. So why is it that doubling the size of a team doesn't mean you get twice as much done? Well, let's see. If you're doing a play that has 5 major characters, and I give you 10 actors, that means you can do twice as much play, right? If you give the director 10 actors instead of 5, they can make something like what they had before, maybe with the same general themes, but it's going to be a different play. It's going to be a different production. And it's the same with software. You can have a 5-person team building a thing, and if you turn that into 10 people, you're not going to build the same thing faster. You're going to build a different thing. It makes sense in that context. Why aren't there reliable metrics for productivity? Since the beginning of software, we've been looking for a number, right? Some number that will help us. But lines of code doesn't do it, churn doesn't do it, test-to-code ratio doesn't do it, velocity doesn't do it. None of them reliably tell you how useful a developer is to your team. And sometimes it's only after someone leaves that you realize how much they kept the team together, maybe in ways that you didn't realize, maybe in ways that weren't code. And with actors, you have the same problem. It's very difficult to measure how disruptive it will be for someone to leave. The difference, I think, is that theater isn't asking for metrics. They don't think that their value can be measured with a number, or that their job can be performed separately from the jobs of other people. But we do, right? We think these things because our profession comes from hardware, which has many more physical constraints than software, and is, in some ways, more similar to building a product. So we've got all 4, which I think is really interesting. But what does it mean exactly? It turns out we're not hardware. Our end game is not a product, any more than Friday night's performance of Macbeth is a product. Our end game is an experience, and it's an interactive experience in which our customers tell us what they like and what they don't like, and we can feed that back into our next release. Software development on a high-function team feels like a creative process. You're making something, right? It should feel like you're all pulling together, like you're set on the same goal, like you're making progress. And since you're the ones with your hands on the canvas, you better make sure that what you're making is the right thing. Because it turns out, when you use the stage as your model for software development instead of the factory or the workshop, what you're doing is you're putting people at the center of the process, and you're making the product nearly invisible, as it should be. Now, we've known for a while that people are the center of software. Software is a team sport, that empathy is a core skill for a programmer, and now we know why. It's because software, when it's done right, is a creative activity. So the stage actually helps us answer these hard problems of software. It helps us break away from our industrial past, forge a way forward. Now, let me be clear that I'm not suggesting you immediately adopt the tropes of the theater in your development team. All of these models can coexist, right? Remember, all models are wrong. Some models are useful, and our models are useful for different things. The factory is helpful for telling us what the rest of the company thinks about all this. This photograph is called Corporate Cliché Shot Number 57. That is the literal title of this photo. I love it. The workshop, the software craftsman stuff, that helps us understand what happens within a development team when you're focusing on the code. Which historically has been our purview, and now we're widening it a bit. But the stage tells us how we work together. It shows us how we relate to each other. It shows us how we keep the joy and creativity in our work, even when we're within a corporate structure that looks like corporate cliché number 57. It shows us what a high-function team looks like. It shows us how people are related to software, which are the hardest part of software. So please take these ideas, use them, nudge your own teams towards higher function. You can do this from the inside. We need more high-functioning teams, and we need more successful projects. We need to build software that matters. We don't need any more car sharing services. We don't need any more ways for teenagers to send each other disappearing messages. Like, we need software that works on actual problems, like violence and poverty and disease. And to solve those problems, we're going to need to be creative. And the way we enable that is by inverting our product-centric model into a people-centric one. And we need to make stuff that matters, and we need to make programming fun again. Thank you.